Ahead, functions. I hope there is a clarity with respect to the functions. All right. So first of all, what you can say that the earth which you used to see, the earth which you see, and the different layers which you see. So sorry, different air or different layers of air you can say, or let's say air which you see. So here we have a air. This is what we have a earth, atmosphere. It's because of the gravity. It's because of the gravity of our earth. It's because of the gravity of our earth. What will happen? That the air which is surrounded or which is surrounding the earth, suppose this is the air. Suppose this is the air. Okay. So we have air around this earth. So let's say this is what the one of the resemblance of the air which is surrounded the earth. Now it's because of the gravity, what will happen? It's because of the gravity, what will happen? That gravity will have some sort of force, and as a result of this, what will happen? That air will be concentrated near to the surface. The more air will be concentrated near to the surface because of the gravity, right? Because of the gravity, you can say. So what we can say that the density of air will be greater near to the surface. Okay, or in other words, I can say that if you move in our atmosphere, if you move in this air, if you move in this air vertically, so there will be a decrease. There will be a decrease in air density. There will be a decrease in air pressure. Now, what is the meaning of pressure? See, I'm not saying atmospheric pressure, I'm saying pressure. So suppose we have this air, okay, suppose we have this air, and let's say with respect to this particular air, it is, let's say, 10 kilometer extended vertically. It means what? That the human who is on the surface, he is bearing the weight of this 10 kilometer by 2 meter, or let's say 1 meter, for example. Suppose you might have seen that 2 by 2 tiles. So suppose if you're standing on this 2 by 2 tiles, now just imagine that from the top, from the surface of our earth till the top of atmosphere, you have what? That much weight of air on you. That is being considered as what? Air pressure. I'm not saying atmospheric pressure, that is a different thing. I'm saying air pressure. So it is the weight of that particular column which is lying on an individual here in this case. So that is what air pressure. So air pressure will also be greater when it comes to the surface. Air pressure will also be greater when it comes to the surface, and as you move vertically in our atmosphere, the air pressure will going to decrease. The air pressure will going to decrease. And one more thing, as here you can see that because of the gravitational, we can say gravitational role, the air which is here, that will be concentrated near to the earth's surface, and that's how you can say that the air which is here, now it will contract. And when the air will contract, its volume will what? Its volume will be less. And as you move vertically in our atmosphere, what will happen? The gravity will be less with respect to this first position, and with respect to the second position. Here the air part, here the air which is located, the air which is located here at the second position, now this air will remain under the influence of gravity, however less than first one. Because of the gravity, the first position which is here this air will be pulled more, and the air which is here at the second position, that air will have a less effect of gravity, and as a result of that, what will happen? Now the particles, or let's say the air which is there, now this air will not going to contract, which is closely packed in this first position. Now here the air which is there, that air will be loose, and what you can say that the volume will going to increase. Volume will going to increase. So it's based on the pattern of earth and gravity. I'll summarize it, that first of all, gravity pulls all gases, and as a result of that, all these gases will be near down to the earth's surface, you can say, and as a result of this rotation and revolution, we have a proper, we can say, spread horizontally or vertically along the surface. Okay, so we have a proper circulation as a result of this particular rotation and revolution played a role in circulation. You'll get a clarity in a while. Now, gravity pulls air molecules towards the earth, I told you, and there is a compression, there is a compressed part near to the surface, and yes, the air which is above that will be thinner, means that will have less set of density. So air density will decrease. This is the pattern and this is the trend, you can say. Air density will decrease if you move vertically in atmosphere. So air density will decrease with height. Then air pressure will decrease rapidly with height. Air pressure will decrease rapidly with height. Suppose if you are here at this first position, you will have to bear this much weight. Suppose you are here, now you have to bear only this much weight. So this is greater, this is less. Okay, so that's why at the surface the air pressure is more, and when you are on the mountain top you will see the less air pressure. It's because you can take an idea of this particular position 1 and this particular position 2. So you have to bear this much weight, less pressure, you have to bear this much weight, more pressure. Okay, so what we can say that the air pressure will also decrease rapidly with increase in height. Then as you move upward, in atmosphere, what will happen that the air's volume will going to increase. Air's volume will going to increase, and the air's volume will going to increase because of two factor: atmosphere pressure and yes, the less influence of gravity. Because of the less influence of gravity, there will be some sort of what we can say expansion, some sort of loose packaging or loosely positioned air particles in atmosphere. Okay, so this is what the pattern. Again I'm telling you, with respect to the volume, as you move vertically in atmosphere, volume will going to increase. If you move vertically in atmosphere, when it comes to the density, so the density will going to decrease. If you move vertically, so the pressure of air which is there, that will going to decrease if you move vertically. Okay, now you will say what will be the temperature, what will be the other thing, you'll get to know about this. Okay, so what we can say, that the air, suppose this is earth and this is what the air, and I hope you remember that the air which is near to the surface, it will have a more density. The air which is near to the surface, on this air there will be more influence of gravity, and as a result of more influence of gravity, you can say that this air is more dense. This air is more dense in terms of its composition. Whereas I hope you learned and I hope you have a clarity that with respect to this, the air which is above or which is here, now this air will have a more volume and this air will have a less density. So here in the atmosphere itself, can't you say that we have a different layers of air? And we have a different layers of air, and so with respect to the position or with respect to the air and its density and its characteristic features, we have what we have layered wise arrangement of our atmosphere. So based on the density, based on the characteristics of air at different height in our troposphere, we used to categorize that in a one specific zone in a broad area, and that is being termed as what layer. That in this layer we have a one specific set of density, we have one specific set of volume, we have a one specific trend of pressure drop. Here we have a second layer which will going to be different from the first one. Here the air density will be different with respect to the third layer. So in order to make this density difference, we have a atmospheric layers. You might have tried to add oil and water together. Both are liquid, but both will not going to mix with each other. Why? Because of the density difference. So here we also have a density difference with respect to the air. It seems that they are mixed all together, but they will never going to mix all together. It's because of their characteristics, it's because of their feature itself. And who is deriving those features here? It's a gravity. It's a earth surface, or you can say gravity. Okay, so here there is more packed, here the air is more dense, and the air which is above, it will be less dense, it will have a more volume. The air which is here, it will have a less volume. So based on these features, if we move vertically, we will have this kind of arrangement. And in order to mark the different density zone, we used to take a categorization of layered wise arrangement of our atmosphere. Layered wise arrangement of our atmosphere. Okay, so based on this pattern, we used to say, that's how we have a layered wise arrangement. And the, the layer which is near to the earth's surface, this will be termed as what? Troposphere. And the layer which is just above the troposphere, that will be known as what? Stratosphere. That will be known as stratosphere. The layer which is above stratosphere, that will be known as mesosphere, thermosphere, exosphere. Okay, so the name which is given, it is actually marking that one separate distinguished zone is there in our earth surface, who is having almost similar density, almost similar set of volume, almost similar set of characteristics, which are categorically being different from the air which is there in the stratosphere, which is categorically being different in terms of mesosphere. You will get to know that what will be the density of air or gases in these layers. Okay, to mark this density difference, we have a layered wise arrangement of our atmosphere. So the concentric layers of air, which we used to see on our atmosphere, that will be the true definition, true resemblance of our atmosphere, comprised of solid, liquid, and gaseous compositions. Majoritarily gaseous compositions will be there. Clear?